Hello, my name is Nataliia Cheilytko, and I'm going to talk today about a semantic vector space model to explore distribution of word senses in Ukrainian. This project is being done on the General Regional Annotated Corpus of Ukrainian, which makes it possible to explore how words and word senses varies and changes over time and across different regions of this large country. So the ground for the vector space model is a concordance metric that we calculated for the most frequent words minus some stop words, and also it was normalized with the pointwise mutual information index to make it less sparse, and as a result we obtained metrics with almost 3K vocabulary elements, and for each word we have those other words with which it occur and the corresponding pointwise index. Then the actual focus of our attention is how words behave in contexts. So for that, we build concordance lines and worked with those lines where we have at least 5 vocabulary words. So for these examples are for the word svoboda, which is freedom in Ukrainian, and each word in the row is vocabulary word that was found in the window 5 plus 5 or 10 plus 10 window. We experimented with both lenses for this purpose. Then what we did, we took this concordance vector for each element of this shortened line and averaged them into a new line for the whole context in such a way where each line is now represented with a single vector that holds information on each word and its concordance, and in such a manner we are able to judge on this particular svoboda in this particular context, not only given these particular words, but also the information of how they occur in our corpus. Then we did several examinations at this point for particular synonyms in order to try this approach and then explore them to a wide range of Ukrainian words. So given those vectors from the previous slide, we put those for our words of interest and plot them with help of a multidimensional scaling technique. So we scaled those vectors down to the 2D space, and here we have two words which actually have completely different meanings. This is svoboda, freedom, and dvihun, which is an engine. And here we have a cluster for svoboda and a cluster for engine, and we see that they do not coincide. Their senses completely different. And then another way to measure our results that we observe in those second order vectors is to calculate pairwise semantic distance or semantic similarity for each words of interest and each word in their particular context or concordance line. And here on this slide we have such an example where two words with a quite similar meaning, engine, one is dvihun two lines, as we remember, has its own average vector, and we calculated the semantic distance for these two lines. And we tried this with our approach, and the distance similarity was quite high. And to compare it with another approach, take the Ukrainian flora vectors and did the same for the same two lines, and here the similarity is lower, and from the context we can judge that these words are really similar. So these value seems more trustworthy. Then we applied the same technique with multi-dimensional scaling for a single word. So we plotted only its concordance lines, second order vectors, and tried to see how those lines distribute in order to try to reveal something interesting, some patterns in the values. The data shows, here I'm going to give you two examples. For example, this vector stays quite separate from the whole area, and it's for the reason because it's the context here is completely different from typical, because it's a joke. It's this context describes a joke about an engine being done from a bucket. So there is a reason for this item being separate from all the others. And another example, here we have a group of values which together are about specific meaning of engine, which is similar to English action. When a movie being shot, a director usually uses the action explanation to start the recording of the video. In Ukrainian, the word motor engine is used for the same purpose, and we have some context lines here, and they quite close to each other. And on this slide, we can consider another example with two synonymous words. One is svoboda, meaning freedom, another volia, meaning both freedom and a will, a desire to do something. And with this plot, we see that these two words overlap, and the analysis of the actual context line showed that indeed volia behaves the same manner as svoboda, meaning freedom, and in this corpus there is no observation of volia acting as will. And then another example with the pair of synonyms, both meaning engine, motor, and dvihun. And this plot is significantly different from the previous one because we have quite a cluster area for motor here and dvihun here, and some overlapping in the middle, which shows that there is some distribution in the spheres and context where these two words are used. Motor is usually used to speak about some common everyday life vehicles, like an engine of a car or whatever, and we use dvihun more often when we are talking about an engine of a spaceship or a nuclear engine, and so on and so forth. So there is, with no change in meaning, we still have some differences in the way how the words are being used, which is essential for our exploration of the trends in the words' behaviors. So with those examples, let me conclude that we believe in the power of this approach and going to continue on a wide range of data. And I would like to thank you for your attention.